Good day, guys. Welcome to GDS Academy. And I present to you today mathematics of finance. So, all right, when it comes to mathematics of finance, these are majorly what you need to know on mathematics of finance. Okay, so we have the arithmetic progression, geometric progression, simple interest, compound interest, annuity, discounting factor, which comprises of this majorly these three: net present value, internal rate of return, and accounting rate of return. So for the sake of this video, I will not be going into any form of calculation. So I'll be introducing you to each and every one of the formula that you need to know on mathematics of finance. So starting with our arithmetic progression and geometric progression. I've made a video on this in our previous class, but I'm going to be making the video on it. So these are the formulas that you need to know for arithmetic progression and geometric progression. So the first one is that you look for the nth term, which is generated by Tn, is equals to a plus what, open bracket, n minus 1, close bracket, g. But if you are given, if last term is involved, then this will be changed to what? L is equals to what? A plus open bracket, n minus 1, close bracket, g. Where our a is our first time and our g is our common difference. But you can have to look for sum of the nth terms. Formulas for AP. So this is all this formula instead of going for AP. Sum of the nth term. Then to be what? Sn over n over 2 close brackets 2a plus n minus 1 close bracket b. That is if you are given the number of terms. But if you are given the last term and you have to look for the number of terms involved, that is, you are given the last term, then therefore your Sn will be equals to what? N over 2 close bracket what? A plus what? N. So all that you need to know is know what when you use each and every of this formula. This is the normal formula to look for the nth term. This is if your last term is involved in terms of you looking for your nth term. Then this is for sum of the nth term, in which you are looking for the sum of 20 term or 30 term. That's just for example. Then you're using this formula. But if you are given a last term and you're told to look for the nth term, then this is the formula that you're using. So this is all that you need to know. This is all the formulas that you need to know for AP. Now without wasting much of your time, let's move to what? Formulas for what? For geometric progression. Now, similar to our arithmetic progression, our nth term here is equal to what? A r to the power of n minus 1, where our a still remain our first term, but our r here represent our what? Common ratio. So for the sake of those that might not know how to get your common difference, alright, your common difference is simply your second term minus first term, or your third term minus second term. Each and every one of the two, depending on how the question is being structured. But for our common ratio is what? It has to do with what? Division and what? Multiplication. Q1 or 3 2 over what? 2 3. It must be equal to what? 2 4 over 2 3. Depending on the way the question is being structured. But if you are giving your last term for geometric progression, the same way I did this is the same way you be doing this. It's just what? L is equal to a to the power of r over n minus 1. Now, for the sum of the nth term of a geometric progression, if your common ratio r is greater than 1, then your sum of the nth term will be equal to what? A open bracket r to the power of n minus 1 close bracket r minus 1. That is if your common ratio is greater than 1. But if your common ratio is less than 1, then your sum of the n terms equals to a in bracket 1 minus r to the power of n close bracket over 1 minus r. Hope you guys understand me. And if you don't, you can always backward the video to understand it very much. Now, the last one for the geometric progression is sum to infinity. So it is just denoted by this, which is equals to what? A over what? Minus r. So this is the formula for what? Sum to infinity. That is that on what? Arithmetic progression and geometric progression. Like I said, I might not be able to do this, the whole of this for the sake of this. So I'll be slashing this into what? Two. I'll be doing this 4 parts for this video and the remaining parts now next video. Then we'll move to question and answers. So that is that on what? AP and GP. Now for the simple interest, So the general formula that we are aware of is for us to get our interest, so that P times R times what T over 100. Then we are told that our amount here is equal to what? Principal times what? Interest. Good. In some textbooks, they might choose not to include over 100 in this. Or some textbooks, they might make use of n. Some textbooks make use of n as their time. Then T will represent the number of times that you are doing it. So I'm now going to restructure this formula to get, if you have to get your amount immediately, it should be what? A is equal to what? Remember, I is equal to, I can also be equal to what? PRN. So this is plus what? PRN. You can factorize, and that is what? P in bracket 1 plus Rn. Then let's leave it this way. So this is the formula for what? Simple interest. Then for the compound interest, the difference there is, so the difference between compound interest and simple interest is the principal for simple interest is fixed. So if you are giving 20,000, it's the same 20,000 that you're using throughout the period. But for compound interest, it is being compounded together. From what compound, you sum it up together. Then the amount summed up, the amount as at the end of the first period, you build the new amount for the what? Second period. Or with the new principal for the second period. So for the compound interest, for this, sometimes it might be compounded monthly, annually, or biannually. So if you are giving that, then you can easily say that our amount is what? P in bracket 1 plus R plus N over what? The amount of times that it occurred in a year. The same thing goes for what? Compound interest. But for compound interest, because it is being compounded together, therefore our amount here was principal open bracket 1 plus what? R, which is our rate in percentage, close bracket, to the power of what? N. Similarly, the amount of time that is popped up in a year, that will be T. So if this is T, then this will be what? Times T. Same thing goes for this, times the amount that is popped up in a year. But this is the general formula for it, or the most common formula for it. But there are some complex situations or some complex questions that might require us to apply this formula and this formula. So this is the formula for what? Compound interest. So without wasting much of your time, this is where I would like to stop our video on. Hopefully you guys should understand the formula that you need to apply in solving it. But before I move forward, if biannually, if I go to compound it biannually, then your T will be what? it will be 2. If it is quarterly, it will be what? Your T will be what? 4. Because you have 4 quarters in a year. So let me leave it for this because this is the most common one that we use in our compound interest. So I hope you guys have been able to understand this question for today. Thank you very much for staying in touch up to this point. Like I promised, I won't miss most of your time. Thank you very much for watching our video. Kindly like and subscribe and share with your friends. See you in our next class. Thank you.